All right, ladies and gentlemen, so today we're going to get into how we can use this idea of similar figures to help us solve some word problems. And a really common example of these is, they're called shadow problems. So the first thing you want to do is to draw yourself a picture, right? So, but it doesn't have to be fancy, all right? So we have here, a person is 6 feet tall, right? So we'll pretend this is our person, 6 feet tall. And they have a shadow that's 2 feet long. So there's my shadow. All right, and again, you don't have to make it look fancy. Well, what happens is that I now can create a right triangle. All right, so I now have a figure here. A tree that is has a shadow that's 8 feet long. So here we would have 8-foot shadow, and here's our tree. Well, again, if I have this, and I want to know, well, how tall is the tree? And I'm going to put an X there. We're now going to use proportions to help us with this. And there's more than one way that you can do this. All right, but I could figure out my scale factor, right? But we're going to just set up a proportion, hopefully, to make it show you another way to do it. So I'm going to compare how tall the person is compared to their shadow. Right, so I'm going to write off to the side what I'm comparing. Person, or object, I really should say, since we're talking about a tree, compared to the shadow. So I have a person who's 6 feet tall, their shadow's 2 feet. I have a tree that I don't know how tall, the shadow is 8. And now I can do some cross multiplying. So 2x, 6 times 8 is 48, and you should know how to finish solving this from back in 7th grade, because Mr. Bush and I spent a lot of time on this. So now we're going to divide by 2. So x would be 24 feet tall is the tree. Right? And if you think about it, that is a scale factor of 4. And if you want to do it as a scale factor, then please go right ahead and do that. I'm fine with that. A flagpole casts a shadow that is 28 feet long. So we have this flagpole. We have the shadow, 28 feet. We have a person who's standing nearby casts a shadow that is 8 feet long. So here's the person's shadow, and they tell us that the person is 6 feet tall. And we want to know, well, how tall is the flagpole? Same idea. I'm going to compare object to its shadow. So x over 28, object, 6, over shadow, 8. Because again, I could easily draw this, and now I have created two similar triangles to each other. All right, so do your cross multiplying. We're going to get 8x equals, oops, that's 42, 6 times, oh my gosh. Sorry. Let's get that correct here. So 6 times 8 is 48. 6 times 2 is 12, so 168. Divide by 8. So x is going to be 21 feet. All right, it works the same idea for rectangles. So a photograph measuring 4 inches wide and 5 inches long, 4, 5, is enlarged to wall mural. If the mural is 120 inches wide, we want to know how long would it be. So this time I'm going to compare width to length. 4 over 5, 120 over x. Cross multiply, we're going to get 4x equals 600. Divide by 4. X goes in there once. 20, 150 inches. All right, here's another type of problem. A giraffe is 18 feet tall. So here's our giraffe, 18 feet. Its shadow is 12 feet. Right, there's your right triangle. Corey is 6 feet tall. How long will his shadow be? So this one's, now we're kind of talking about a reduction here. So we have the object over its shadow, object over shadow. So 18x equals 72. Divide by 18, and you should get 4 feet. All right, let's see. Do we have any others? Nope. Now we're going to get into practice. Okay, so it's about kind of drawing your picture. Again, if you want to use scale factor, figure that out and then either multiply or divide by the scale factor. That's okay, but I wanted to show you proportions as well to kind of bring in some stuff you did last year. Any questions? Bring them to class and have a good night.